Hi, I'm an old guy and I do maths. And today we have an interesting problem. Y equals a e to the negative bx. We're tasked with finding a and b, and we're given these two sets of points, 350 and 610, and told that they lie on the graph of this function. Well, we can't do everything at once, so we're going to go after either a or b first, and I think it's easier to go after B, and hopefully my reasoning for that will become obvious as I take you through my technique. It's not my technique, the technique I used, which is everybody's technique for finding B. Now, generally speaking, before we get into this, when you're given a function and there are some elements missing from it, so it's got some pronumerals in there that you have to find. A basic technique is to use simultaneous equations, and essentially that's what we're going to do to find b. Because we're dealing with logs here, there's a slight twist on what we do, but I'll get to that. Okay, so what I did to start with was I set up two equations using these points. So I've got ae to the negative 3b equals 50. That's my first equation using these 2 points. And ae to the negative 6, please be aware that's a 6 and that's a b, equals 10 using the second set of points, 6 and 10. Now, the normal process when, for instance, you are doing something like this with a quadratic or a cubic or whatever, a non-log problem, put it that way. The normal process is that you would subtract one from the other. That's not going to work here because just looking at this, what we want to eliminate is a. We're not easily going to eliminate b. So what we're going to do is we're going to try and eliminate a and then find a value for b. Now, subtraction won't do this. What we're going to have to do is we're going to have to use division. And that's a key thing when it comes to doing this with logs. You're usually in the business of division. Okay, so let's see what happens when we divide 1 by 2. This is what we get. So the a's are eliminated. A divided by a is 1. The laws of indices kick in here, and when we divide this by this, what we're doing is we're taking negative 3 and we are subtracting negative 6 from it. So we wind up with 3b. And we wind up with this expression 1e, and we can drop the 1 later, to the power of 3b equals 5. Now, if we write this as a log that we might recognize, what we get is this. So you rewrite this in log form, and you get log e of 5 equals 3b. Now we are well on the way to isolating this value b. All we have to do here is divide both sides by 3, and we will get a value of b. Now, there are two ways in which this works, and I've got them both outlined here. So we can write b as equaling this expression, or slightly more neatly, we can write it as this expression here. So we now have a value for b, and it's our job now to insert this into our equation and use some of the points that we were given to find a, and that's the second part of this. So what we've achieved so far we have done by use of a simultaneous equation, and the slight variation on what you would normally do is that instead of subtracting or adding, we've resorted to division because we had to deal with this thing here. Okay, so let's get on to the second part of this. Now I've prepared this so that I can talk and point to things and my hand doesn't get in the way. Now, one of the rules that we're going to be relying on in order to do this is off here to the right of the screen. Now, the rule is usually stated in this form, but basically this expression here is equal to this. Now, we have been using this form, so this and this are exactly the same. They're just different forms of the other. So we're going to apply this rule. So let's get into this. Here's our basic equation. So here I have inserted the values that we know. We don't know A. We have 2 points, 6 and 10, and we have a value for B. So what we know is that 10 is equal to this, and with a bit of rearrangement, we can find out what A is. So let's do some tidying up. Now I've simply rewritten this in this form. So this and this are exactly the same, and so that's all I need to say about this line. The second line here, this line, is where I've tidied this up. So -6 times 1/3 gives us -2, and so we're edging towards something tidy here. So we can rewrite this as this, using the rule about the multiplication of logs. We can move this -2 to here. So what we know now is that AE to the power of this is equal to 10, and this we can write as 1/25. It's really up to you whether you do this first or you get rid of the log. It's your choice. I did this first, and this is what I've got. So AE log of 1/25 is equal to 10. Well, we can put a line through this and rewrite this as A times 1/25 is equal to 10. It doesn't take much work to get from here to our answer, which is A equals 250. So this lovely equation is as follows. Y is equal to 250 E to the negative 1/3 log e to the 5 x. And that's it. We've got that. Remember that this was negative b and we had to find b, and we've got a. There we are. Thank you very much for watching. I know that was a lot to take in. This is yet another problem that was referred to me by a student, and it took a bit of searching of the memory banks to figure out how to do this. Anyway, thanks for watching. If you found this useful, please like and subscribe, and I'll see you next time. Bye.